My name is Dr. Esther Trufan, and in this video, we're going to explore the extraction of calcium from eggshells. There are two steps to this process. The first step is to take our calcium source, which in this case is the eggshell collection, or the crushed eggshells that we placed in the cup, and extract all the calcium from it by converting the calcium carbonate to a more soluble form of calcium, which in this case is the calcium acetate. We accomplish this process by adding vinegar or acetic acid to our calcium carbonate or eggshells. And if we do this for long enough, then all our calcium will be converted from calcium carbonate to calcium acetate. The carbonate will react with the hydrogen released from the acetic acid to produce carbonic acid that easily decomposes into water and carbon dioxide. And we see a lot of bubbles as we are performing this experiment. For this process, it is essential that our excess reactant, the one that we use in an overwhelming amount, be the acetic acid. This ensures that all the calcium from the calcium carbonate is fully reacted. The species in the solution at the very end are going to be the calcium acetate, which is an ionic compound that easily dissociates in water to release calcium ions and acetate ions. We will also have a small amount of hydrogen because we're using excess acetic acid, and we're also going to have acetic acid because as a weak acid, it partially ionizes in water, meaning that the majority of it is still present as acetic acid. Once we accomplished our task and all the calcium has converted to calcium acetate, we can move on to our second step. Now, in the second step, we recognize that in addition to the calcium acetate in solution, we also have some of our excess acetic acid. When we add our precipitant, the sodium carbonate, it will react with both of those. So when the calcium acetate reacts with the sodium carbonate, it will produce calcium carbonate, which is a white precipitate, and it will crash out of the solution. It will also produce sodium acetate, and that is soluble in water and it will be dissolved. So as we do our filtration, the only thing we will collect is the calcium carbonate. However, in the previous reaction, we saw that when we have calcium carbonate and acetic acid in the same mixture, the two of them will react. So it is essential that our excess acetic acid be neutralized by the sodium carbonate. So in this reaction, that is really a two-component reaction, we have to ensure that the sodium carbonate is the excess reactant and it is provided in a substantial enough amount to react with both the unreacted acetic acid from the previous step and all the generated calcium acetate from the same reaction. The species in solution will then be the sodium ions and the acetate ions. These are going to come from the dissociation of sodium acetate, sodium ions and carbonate ions, which will come from the dissociation of our excess sodium carbonate. And the only thing that precipitates out of this solution is going to be the calcium carbonate. And so if we perform a filtration and we rinse our precipitate well with water, we should be able to eliminate all the ionic components and recover only the calcium carbonate on the filter paper.